All right, let's start on task 2. We are going to start doing square roots, but this time we're going to add in some variables, some x's and y's. Now, when we think about perfect squares, we have our perfect square list from last class, but perfect squares of variables are even numbered exponents. Essentially, x squared is the same thing as x times x. There's two of them and multiplied times itself. X times itself is x squared. So the square root of x squared is just x. The square root of y to the fourth is actually y to the second. The square root of x to the sixth is actually x to the third. Essentially, we're going to divide exponents by 2. So y to the 100th power, when I take the square root of it, I get y to the 50th power. Those are my even exponents. What gets a little bit funky is when I get something like an odd exponent, x to the third power. I know the square root of 4 can come out of my square root symbol, but I want to break this x to the third down into a perfect square. X to the third is the same thing as x times x times x. I have 3 x's there. So I have 2 x's and another x. I could break x to the third down into x squared times x. They are the same thing. X squared times x equals x to the third. I'm just breaking it down. So let me break down this square root into my perfect squares. 4 is a perfect square. X squared is a perfect square, and I have an x hanging out because I have actually 3 x's underneath there. And of course, all of my perfect squares, they get to come out of the square root symbol. So the square root of 4 is 2. X squared, the square root of x squared is just x, and then I'm left with an x underneath that square root symbol. So all of my variables, I'm going to break down into an even numbered variable and one left over. So y to the fourth is already an even numbered variable. X to the fifth is not. Let's keep y to the fourth as my perfect square, but x to the fifth, I'm going to break it down into an even variable and then one more. So x to the fourth and x would give me a total of x to the fifth. And these y to the fourth and x to the fourth are my pieces that can come out. When I divide by 2, I get y to the second, x to the second. I'm left with this one little x left over in my square root symbol. Last example, 16 is a perfect square. X to the sixth is an even exponent. It's a perfect square. Y to the third needs to be broken down. So let's rewrite this. Perfect squares are 16, x to the sixth, but then this y to the third needs to be broken down very similar to what I did up here with a x to the second and x. I'm going to have y to the second and y. And this y is going to be left over. Everything else is a perfect square. 16 gets to come out, x to the sixth gets to come out, y to the second gets to come out. The square root of 16 is 4. When I take the square root of x to the sixth, it becomes x to the third. I'm dividing by 2. Square root of y to the second is just y. And I have a y left underneath. Pause and see if you can do question number 1. Break down into perfect squares and even exponents.